It's beginning to look a lot like Christmas everywhere you go.
Alright guys, so I'm going to go over the solutions for notes 5.4. Really quickly, there are two different types of reactions that we're looking at. The first is a synthesis reaction. And keep in mind, for a synthesis reaction, just as a quick review, you have two individual elements combining together to form one. For this type, you've got a metal oxide, so a metal with oxygen reacting with water, and it forms a base. And keep in mind, a base is simply a metal that is chemically combined with hydroxide. And then finally, for the type C, you've got a non-metal oxide reacting with water. And remember, that forms an acid. And an acid is hydrogen, followed by a non-metal, followed by oxygen. All right, so let's look at these examples. Okay, so for these, I wanted you to write out what was formed and then also note what is being oxidized and what is being reduced. So for the first one looking at this is a type A because you've got two individual atoms combining together. So to form that compound, I need to cross their charges. Remember, the charge of aluminum is 3+, the charge of oxygen is 2-. So when I cross my charges, I get Al2O3. I need to balance, so I put because I've got 2 oxygens here and 3 here. So I put a 2 in front and then a 3, and then that gives me 4 aluminums, 4 aluminums. Now I need to figure out oxidation numbers. Aluminum and oxygen are by themselves, so they have 0 oxidation numbers. For oxygen here, oxygen is always -2 for its oxidation number, unless it's a peroxide, so like H2O2, for example, in which case it's -1. I've got 3 oxygens, so that overall gives me a -6 oxidation number. Since my oxidation numbers need to add up to 0, because there's no charge for this compound, this would be a +6 overall oxidation number. But since I have 2 aluminums, that means each aluminum will have a +3 oxidation number. So since aluminum is losing electrons going from 0 to +3, it's being oxidized, while oxygen gains electrons, it is being reduced. Here I've got aluminum oxide with water, so this is a metal oxide reacting with water, so that's going to form a base. Remember, a base is simply your metal crossed with hydroxide. Your metal here, aluminum, has a 3+ charge. Hydroxide is 1-, so when I cross my charges, I get AlOH in parentheses 3. I need to balance, so I put a 2 here to give me 2 aluminums. Then that gives me 6 hydrogens because I've got a 2 and a 3 here. So need to put a 3 here to give me 6 hydrogens. Then I've got a total of 3 plus 3 oxygens, so 6 oxygens. That would give me 6 oxygens there. For determining oxidation numbers, remember oxygen is always -2, so -2 times 3 gives me -6. Aluminum, therefore, needs to have an overall +6 oxidation number, so those would cancel. So therefore, each aluminum has a +3 oxidation number. Keep in mind, when I ask you what is the oxidation number, you need to say +3 and -2, not +6 and -6. That would be wrong. For water, -2 for oxygen. That means hydrogen overall needs +2. Therefore, each hydrogen has +1. Okay, for here, I like to, when I have a polyatomic ion with a subscript, it kind of overwhelms me a little bit determining oxidation number, so I actually like to break them up into their ions. So aluminum has a 3+ charge. Hydroxide has a 1- charge. That makes determining oxidation numbers very easy. Aluminum has a +3 oxidation number because that's the charge of that ion. Hydroxide, oxygen is -2, hydrogen is +1. That gives me a -1 charge. Which means, if you notice, none of my oxidation numbers are changing. They're all staying the same. Therefore, this is not a redox reaction. And finally, for 3, CO2 plus H2O, because this is a nonmetal oxide, this is going to form an acid. Acids, remember, are hydrogen, followed by a nonmetal, followed by oxygen. So I can balance as I go for this reaction, which is wonderful. Only for type C can I balance as I go. So I have 2 hydrogens there, so I'm going to put H2, followed by 1 of my nonmetal carbon, followed by 3 oxygen. So that's H2CO3. For determining oxidation numbers, I've got 2 oxygens, -2, so that gives me -4. Therefore, carbon has to be +4. Water, oxygen is -2. That gives an overall -2, which means hydrogen has to be +2. Since I have 2 hydrogens, though, each is going to have an oxidation number of +1. And then finally, for here, oxygen is -2. I have 3 of them, so that's -6. Hydrogen is always +1, unless it's with a metal, and then it would be -1, but it's +1 here, so that would be +2. So overall, this needs to have 0 for its charge, plus 2 minus 6. I need plus 4 for the oxidation number of carbon. So notice none of my oxidation numbers, all of these guys on the bottom, change. Therefore, it is not a redox reaction. All right. The second type of reaction we're going to talk about are decomposition reactions. So in a decomposition reaction, what happens is that a single compound will break apart into 2 or more than 2 different substances. Just the opposite of a synthesis reaction where elements actually, or compounds, come together to form one compound. So I've got all of these different types here. Notice some of them are the exact opposite of what we had for synthesis. So A here, right, we had seen A plus B produces AB. For D here, we had a metal oxide in water producing a base. Here, there's your base right there, but it's just flipped. And then finally here, you've got an acid breaking apart when before we had a non-metal oxide in water reacting to form an acid. Alrighty, so let's look at this. For number 1, lithium chlorate. So looking at my examples here, this would be a metallic chlorate. So you'd have lithium chlorate here. So I need to form lithium chloride and oxygen. So remember, lithium has a +1 charge, chlorine has a 1- charge. This would just be LiCl plus oxygen. I need to balance. I've got 3 oxygens here, 2 oxygens here, so I need a 3 in front here and a 2 in front here. Then to make 2 lithium chlorides here, I need to put a 2 in front here. For oxidation numbers, oxygen has a -2 oxidation number always, which makes this -6. Lithium's always +1, which means chlorine, in order for these to add up to 0, chlorine needs to be +5. So these are my oxidation numbers for lithium, chlorine, and oxygen respectively. For lithium chlorine, chlorine is -1. Why? Because lithium is always +1. And then here, oxygen is 0 because it's by itself. So notice chlorine is going from +5 to -1, which means it is gaining electrons, so it is being reduced. Oxygen is losing electrons, going from -2 to 0, so it is oxidized. For number 2, you've got a binary compound, meaning just 2 different elements, so it will decompose simply into its elements. So you've got Pb and O2. Be careful, oxygen is one of your 7 diatomic elements. I've got to balance by putting a 2 in front of your 2 different Pb's. And then I've got to figure out the oxidation number. So Pb has an oxidation number of +2. Why? Because oxygen is -2, and they need to add up to give you 0. Pb is 0 and oxygen is 0 here because they are by themselves. So Pb here goes from +2 oxidation number to 0, so it is gaining electrons, it is reduced. Oxygen goes from -2 to 0, it is losing electrons, so it is oxidized. For number 3, notice I have an acid, so this is a type F, where I have an acid breaking apart into a nonmetal oxide and water. Keep in mind for these, just like the synthesis reactions, this is going to be a balance as you go. So I like to write water first. Remember, the order in which you write these doesn't matter. But I have water first, and then I need to put my nonmetal. I've got 1 sulfur here, so I'm going to put 1 sulfur here. And then I have 3 oxygens on my reactant side, 1 already from water, so that's going to be O2. To determine my oxidation numbers, oxygen has a -2 oxidation number. I have 3 of them, so that would be -6. Hydrogen's always +1, so that'll be +2. Therefore, for all of these to add up to 0, sulfur has to be +4. So those are my oxidation numbers there. Oxygen's -2 here. Hydrogen is +1, so you can just check it, that works out. Here, oxygen's -2, there are 2 of them, so that's -4, so sulfur would have to be +4. Notice my oxidation numbers are not changing, therefore this is not a redox reaction. And finally for 4, this should not be A, this should be a B. This is a metal carbonate, so it's going to form a metal oxide and carbon dioxide. So my metal here is calcium with a 2+ charge, oxygen has a 2- charge. When I cross my charges, I get Ca2O2. They cancel, giving me just calcium oxide and carbon dioxide. For my oxidation numbers here, -2 for oxygen times 3 gives me -6 overall. Calcium is +2 always for oxidation numbers, which means that carbon will be +4, so that these all add up to 0. Oxygen here is -2, calcium's +2. Here oxygen's -2, there are 2 of them, so that's a -4 overall oxidation number, which means carbon needs to be +4, so they add up to 0. So when I look at all my oxidation numbers, none of them change, therefore this is not a redox reaction. Finally, for number 1 here for the checking in, this is a synthesis reaction. I've got 2 different substances combining together to form one. All right. It is going to be a type C. I'm forming an acid. So since I'm forming an acid, remember these are balance as you go, so no crossing of charges. I've got 1 sulfur here, so I know my nonmetal, I'm just going to have 1 sulfur. I've got 3 oxygens here, 1 here already, so I just need 2 here. So SO2 reacting with water gives me H2SO3. And then finally for 2, this is a metal carbonate. This is a decomposition because it's breaking apart. It is a type B reaction. I'm going to form a metal oxide and carbon dioxide, and you can see that by just looking at the reaction here, metal oxide and carbon dioxide. So my metal here is sodium. I need to cross sodium's charge of +1 with oxygen's charge of 2-. I get Na2O, and my other product is CO2. When I look to balance, I'm actually already balanced. I've got 2 sodiums, 1 carbon, and 3 oxygens on both sides. And that's it.